not all functions that we want to integrate can be reduced to a simple form or can be reduced to a standard form by doing a simple substitution. Now, what do we do in cases like this? In this lesson, we will develop a unique method of integrating some such functions. Now, the method that we developed today is called integration by parts. Now, what does it involve? This method, the quantity to be integrated is broken into two parts. Now, one part we will call u, and the other part we will call dv. If you have identified one part as u, then its differential will be du, and the other part will be dv, and by integrating dv we must be able to obtain v. Now that means the part that you call dv must be a part that can be easily integrated. Well, I will illustrate that by taking some examples. So, the part that we call dv must be a form that can be easily integrated. So, once we have identified u, du, dv and v, we will use a formula that is developed by somebody who worked on this to do our integration. And this is the formula that you need to remember. Integral u dv equal to uv minus integral v du. So, once you have a quantity to integrate, we identify one part of it as u, and the other part will then be called dv. Now remember, the part that you call dv must be a form that can be easily integrated. So once you have u, then you can find du, and you have dv, integrating it will give you dv. So these are the four quantities you need. Once you have these four quantities, the integral of u dv is uv minus integral v du. Alright, let's practice that with this example. Evaluate the integral x e to the power of x dx. And this doesn't actually belong to any of the forms that we discussed so far. That means it cannot be integrated in the normal way. Now, how will we split this into u and dv? What will be your u and what will be your dv? Well, in cases like this, it is conventional that you take x as your u and e to the power of x dx as your dv. Now the dx always go with the dv part. So first we identify u and dv. In cases like this, the quantity when repeatedly differentiated will give you 0 will be your u. What does that mean? If you have an x, the derivative of x is 1 and the derivative of 1 is 0. If you continuously differentiate, you end up 0. So in cases like this, that will be your u. So in this case, your x will be your u. So we start by saying u equal to x, and therefore du equal to dx. We have those two quantities now. Now, if x is our u, then the remaining is e to the power of x dx, and that is our dv. Alright, if dv is e to the power of x dx, then what is v? Integrate both sides of this. We get v equal to integral e to the power of x dx, and integral of e to the power of x dx is e to the power of x. So we have u, we have du, we have dv, and we have v. We can now write this integral using the form that we have. Integral x e to the power of x dx is integral u dv. X is our u, e to the power of x dx is our dv. And what is that integral equal to? This is the formula that you need to remember. Integral u dv is u times v minus integral v du. Alright, so u times v, so that will be x times e to the power of x minus integral v du. V is e to the power of x, du is dx, so that will be x e to the power of x u times v minus integral v du. That's our v, this is our du. Now, this is easily integrated. What is integral of e to the power of x dx? Is e to the power of x. So that will be, now watch this again. That is our u. This is our v, so that is u times v minus integral v. This is our v and this is our du. Now what does this equal to? This will be, that remains the same, x e to the power of x minus integral e to the power of x dx is e to the power of x. So that will be x e to the power of x minus e to the power of x plus c. And you can factor out an e to the power of x. So the result is e to the power of x times x minus 1 plus c. So you can see by integrating this by parts, it was actually made very simple. Alright, another example. Evaluate integral x sine x dx. Now here again, it's the basic form, is the same as before. You see, x is something that when you differentiate continuously, it is going to become 0. So we're going to choose x as our u, and the remaining sine x dx will be our dv. So u equal to x, and what is the next step? Find du. Therefore du equal to dx. Then remaining, our dv is sine x dx. Alright, if dv is sine x dx, what is v equal to? V will be integral of dv, and therefore integrate the right hand side. V equal to integral sine x dx. What is integral of sine x dx? Alright, it is negative cos x. So again, you have u, you have du, you have dv, and you have v. We can use them to write our integral using the uv form. So what does this become now? Integral x sine x dx is, x is our u, sine x dx is our dv, and what is the form of this integral? That will be u times v minus integral v du. What is u times v? U is x, v is negative cos x, so that will be x times negative cos x, that is u times v, minus integral v du. V is negative cos x, du is dx. So once again, this is our u, and this is our v, that gives you uv. This is the v, and this is our du. And what does this give you? This will be negative x cos x minus, what is integral of negative cos x dx? Integral of cos x is sine x. Integral of negative cos x is negative sine x. Alright, so that will be negative x cos x minus integral of negative cos x dx is negative sine x. And now the two negatives become positive, so your answer is negative x cos x plus sin x plus c. Okay, another one. Evaluate integral x squared e to the power of 2x dx. And this is our integration by parts formula. Carry that with you for every problem. Integral u dv is u times v minus integral v du. Alright, can you help me identify u and dv here? In expressions like this, not every time, but expressions like this, I will explain the meaning of that like this a little while after. You can see if you take the derivative of x squared, it is 2x. The derivative of 2x is 2. The derivative of 2 is 0. Continuous differentiation lead you to 0. So your u is x squared. If u is x squared, what is du? Du is the differential of u, and therefore you take the differential of the right hand side, that will be 2x dx. So du equal to 2x dx. If x squared equal to your u, then the remaining e to the power of 2x dx must be your dv. So your dv is e to the power of 2x dx. Alright, tell me, what do you get if you integrate e to the power of 2x dx? Integral of e to the power of ax is e to the power of ax divided by a. Now don't confuse between integration and differentiation. Derivative of e to the power of ax is a e to the power of ax. Integral of e to the power of ax dx is e to the power of ax divided by a. So if dv equal to e to the power of 2x dx, then v will be integral e to the power of 2x dx, and that will be e to the power of 2x divided by 2. Again, you have your u, you have du, we have v and dv. Let's write down the integral. Integral x squared e to the power of 2x dx is, x squared is u, this is our v, so that will be u times v. U times v is x squared times e to the power of 2x over 2, is that right? So it will be u dv, integral u dv is uv, look at that one, minus integral v du. So we have u times v is x squared times e to the 2x over 2, that is u times v, minus integral v du. V is e to the 2x over 2, and du is 2x dx. Alright, here 2 and 2 will cancel. You have x squared e to the power of 2x divided by 2, and that is that term, minus integral x times e to the power of 2x dx, because the 2 will cancel. Well, we are now faced with another problem. This cannot be easily integrated. That means you need to now do integration by parts on this one more time. That means you got to call u equal to x. So if you are following me, this integration can be done only using integration by parts. So we use that u equal to x, and e to the power of 2x dx will be our new dv. So that will be, if u equal to x, then du equal to dx. If dv equal to e to the power of 2x dx, then v will be integral of this, which is e to the power of 2x divided by 2. So that means we are doing once again integration by parts here. That means it will be x squared e to the power of 2x over 2 minus, you need to now put a bracket. The integral of this will be uv minus integral v du. Is that right? Okay, let's do that. So that will be x squared e to the power of 2x all over 2 minus. Now in the bracket we are going to write the expression for this integral. This is our u, this is our dv, and you have du and v. This will be u times v, u is x, v is e to the power of 2x over 2, so that will be uv minus integral v du e to the power of 2x over 2 times dx. Well, in our next step, we simplify this. What does that give you? And that will be, you can do that integration. Is that right? What is integral e to the power of 2x over 2? Well, integral of e to the power of 2x is e to the power of 2x divided by 2. And combining with this 2, the denominator now will be 4. So integral of e to the power of 2x divided by 2 is e to the power of 2x divided by 4. So you can see all these terms remain the same, and the only change in this step is integrating this. Integral e to the power of 2x over 2 dx is e to the power of 2x minus 4. What will be the next step you do? You can distribute that negative sign. So that will be x squared e to the power of 2x divided by 2 minus x e to the power of 2x divided by 2 plus e to the power of 2x divided by 4. And simplifying this, you can take something common factor. What are common in here? You can see e to the power of 2x is everywhere, and a 2 on the denominator is also everywhere. But if you notice, I have taken e to the power of 2x divided by 4 as the common factor. Now, that's easy because what all you need to do is make that denominator 4 by multiplying numerator and denominator by 2. So when you take 4 as the common denominator, the numerator in these two cases will multiply by 2. Okay, if e to the power of 2x over 4 is taken out as common factor, what is left in the first term? The first term will be 2e to the power of 2x. Where does that 2 came from? Because we factored out a 4 from here. That can be done only if you multiply numerator and denominator by 2. That makes the denominator 4, which comes out and leaves the 2 on the numerator. So when e to the power of x over 4 is factored out, you are left with 2x squared there, minus, when e to the power of 2x over 4 is factored out here, what is left there is 2x. So that is 2x squared minus 2x plus 1 plus c, and that is the result of integrating this. You notice that here we did integration by parts twice. We had to repeat it. There's actually a simple way for doing this, and I'm going to illustrate that. It's called the table method. We can actually construct a table for integrals of this form. Remember, you cannot do that for any form. In cases where continuous differentiation of u gives you 0, and the dv when you integrate will keep the same identity. What does that mean? You see, e to the power of 2x, when you integrate you get e to the power of 2x over 2. And when you integrate that, you get e to the power of 2x over 4. And if you integrate that, you get e to the power of 2x over 8. You can see the same form keep coming back every time. And that is the form of dv that will suit for the table method. So there are two conditions to be satisfied if you want to use table method. What are the conditions? One is the quantity you choose as u. When you differentiate it continuously, you must get 0. In other words, if you have x to the power of 4, when you differentiate x to the power of 4 continuously, you get 0. The derivative of x to the power of 4 is 4x cubed. The derivative of 4x cubed is 12x squared. The derivative of 12x squared is 24x. The derivative of 24x is 24. And the derivative of 24 is 0. You can see ultimately you reach 0. And the dv must be such that when you integrate it continuously, the same form must come back. Like, if dv is sine x, you can see integral of sine x is negative cos x. But integral of negative cos x is negative sine x. You can see you come back with the same form. So if you keep integrating, you keep getting back the same form. So once again, in cases where continuous differentiation of u gives 0 and the continuous integration of dv keep the same form or the same identity, then we can use a quicker method. Again, a warning for you, this is only possible for this particular case where u and dv satisfies this particular form. Now, for example, quantities like x to the power of n, e to the power of mx, this will satisfy that, because x to the power of n, when you differentiate continuously, you will reach 0. And e to the power of mx, when you integrate continuously, you will keep the same basic form. Integral of e to the power of mx is e to the power of mx over m. And you integrate that again, you get e to the power of mx over m squared. Is that right? If you integrate it again, you get e to the power of mx over m cubed. You can see you'll keep getting back the same form. Or x to the power of n cos mx or sine mx. They're both the same. So these are the forms that will suit the table method. You cannot really use any other method. Now, how do you construct a table? Follow this method. Construct a table with u in the first column and dv in the second column. So you got u in the first column and dv in the second column. Let's take this example. Consider the example integral x squared e to the power of 2x dx. This is the one we just did, and we obtained the result for that. Alright, so in here we write u below u and write dv below dv. And what is our next row? In our next row, we find the derivative, differentiate u continuously and write the results in rows below until you produce 0. So differentiate u continuously and write them rows below. So the derivative of x squared is 2x. The derivative of 2x is 2. And the derivative of 2 is 0, and you have reached 0. That's what this means. Differentiate u continuously and write the results in rows below until you reach 0. And what is the next thing? Go to the next column. Integrate dv continuously until you reach the last row. The last row is the row that contains 0. You don't go beyond that. Well, Integrate dv continuously and write the results in rows below. Tell me, what is integral of e to the power of 2x? Integral of e to the power of 2x is e to the power of 2x divided by 2. Let's write that here. E to the power of 2x divided by 2. What do you get if you integrate this? Integrate e to the power of 2x divided by 2 will be e to the power of 2x divided by 4, because one more 2 will come down. So that will be the integral of integrate e to the power of 2x divided by 2 is e to the power of 2x divided by 4. And what do you get if you integrate this? It will be e to the power of 2x divided by 8. That's right. Okay, now we have completed that. What is the next thing? Assign alternatively positive and negative signs to u and du. So, if the u is positive, then the next du will be negative, the next will be positive, and the next will be negative. Assign positive and negative signs to u and du values, and that's what I have done here. Then multiply values below u with the values below dv. That is, if you choose this value of u, multiply this u with diagonally opposite dv. Look at that. This way, multiply this way. Multiply this u with that v. This is of course v. So this is u times v. Alright, so multiply this and write down that is your first term. So what is our first term in the integration? It will be x squared e to the power of 2x divided by 2. That is the first term. X squared e to the power of 2x divided by 2. What is the next term? Multiply the next du term with that dv. Let's go like that. But that is minus 2x e to the power of 2x divided by 4. Minus 2x e to the power of 2x divided by 4. And next one is 2 multiplied by e to the power of 2x divided by 8. So that will be plus 2 e to the power of 2x divided by 8. And we have done, because if you now multiply with 0, that will be 0. So that is the end, and then you have a C. And this, you know, we simplified and got this e to the power of 2x divided by 4 times 2x squared minus 2x plus 1 plus c. This is the one we did earlier. Alright, so practice this table method. It's a very simple method, but it can be applied only for integration forms of this type. Okay, just practice this with another example. Use table method to evaluate the integral x cubed cos 2x dx. Alright, what is your u? U is x cubed, and your dv is cos 2x dx. So u equal to x cubed, dv equal to cos 2x dx. Let's make our table. Now write your u and write your dv. What is the method now? Differentiate u continuously and write below in rows until you reach 0. The derivative of x cubed is 3x squared. Is that right? So that is derivative of x cubed is 3x squared. What is the derivative of 3x squared? Will be 6x. And what is the derivative of 6x? Is 6. And what is the derivative of 6? That is 0. So we differentiate x cubed continuously with respect to x until you reach 0. Now on the right side, what do? We integrate dv. This is our dv. Integrate dv continuously until you reach the last row. Alright, what is integral cos of 2x dx? Now there must be a dx there, because your dv is cos 2x dx, so don't ignore that. Integrate cos 2x dx will give you, alright, talk to yourself, integral cos 2x dx is sine 2x divided by 2. Remember, integrating cos will give you positive sine. Integrating sine will give you negative cos. So integral cos 2x dx is sine 2x divided by 2. Alright, integrate that again. What do you get if you integrate sine 2x divided by 2? There's of course a dx there, don't ignore that. Integral sine 2x over 2 dx will give you negative, see, integrating sine 2x will give you negative cos 2x over 2. And that 2 will combine with this 2 gives you a 4. So that will be negative cos 2x over 4. And what do you get if you integrate this? Integral of negative cos 2x over 4 dx will be negative sine 2x divided by 8. There you go. Alright. Now if you integrate that, what will be that? Write that on your own. What is integral negative sine 2x over 8 dx? What does that give you? Integral sine 2x dx is negative cos 2x over 2. So that negative and this negative will make it positive. So that will be positive cos 2x over 16. That's right. So we integrated cos 2x continuously. And how do you pick our answer? First of all, assign the sign. Start with positive. Is that right? So assign alternating signs for u and dvu. That will be positive. This will be negative. That will be positive. That will be negative. And positive. Well, we don't need this because we will not be multiplying with 0. So what is our first term? Pick your first term like this, diagonally. It will be positive x cubed times sine x over 2. There you go. X cubed times sine x over 2 is the first term. What is the second term? Minus, you see that there's a minus there and a minus here. When you multiply the two negatives, it will become positive. So that will be plus 3x squared cos 2x over 4. You see how the plus came? Because of the two negatives. That would be plus 3x squared times cos 2x over 4. And the next one, this is positive, that is negative, so that will be plus 6x times sine minus sine 2x over 8 will be minus 6x sine 2x over 8. Is that right? And the final one will be, that's minus, this is plus, so the result will be minus. That would be 6 cos 2x over 16. That's right. And you can simplify some of these. And that will be x cubed sine 2x over 2 plus 3x squared cos 2x over 4 minus 6 and 8. You can divide by 2. That will be 3x sine 2x over 4 minus 3 cos 2x over 8. Again, you can divide by 2. Plus c, and that will be, I have factored out cos 2x over 8 from these two terms. Look at that, cos 2x over 8. Watch that carefully. I factored out cos 2x over 8. That means this will multiply by 2, leaving a 6x squared there and a minus 3 there. I hope you understood. Now, collect these two terms and factor out cos 2x divided by 8. That means you need to make this 8 by multiplying both numerator and denominator by 2. That will make that 3 as 6. So cos 2x divided by 8 comes out, leaving as 6x squared minus 3. And how about the first and third? What would you take out? You can take out sine 2x divided by 4. That will leave a 2x cubed in the first one and minus 3x in the next one. And so that will be the answer. Cos of 2x over 8 times 6x squared minus 3 plus sine 2x over 4 times 2x cubed minus 3x plus c. I know most of you struggle with these kind of simplifications. So look at those again and make sure that you understand that simplification. Alright. Another one. Use table method to evaluate the integral. Integral x to the power of 4 e to the power of negative x dx. That must be easy for you now, is that right? Our u will be x to the power of 4 and your dv will be e to the power of negative x dx. Let's construct a table. Well, below u, you write x to the power of 4. Below dv, you write e to the power of negative x dx. Well, I have been dropping that, but that should be there. Your dv is e to the power of negative x dx. Okay, now differentiate x to the power of 4 continuously until you reach 0. The derivative of x to the power of 4 is 4x to the power of 3. So 4x to the power of 3. The derivative of 4x to the power of 3 is 12x squared. The derivative of 12x squared is 24x. And the derivative of 24x is 24. And finally, the derivative of 24 is 0. We have reached 0 and we stop there. We now go to the right side and integrate e to the power of negative x dx continuously. What is the integral of e to the power of negative x? It is e to the power of negative x divided by negative 1. So it is negative e to the power of negative x. So integral of e to the power of negative x dx is e to the power of negative x times negative 1. So that is negative e to the power of negative x. Okay, what do you get if you integrate this? Negative e to the power of negative x. Now remember, integrating will produce a negative, and that negative and this negative will make it positive. So integral of this will give you positive e to the power of negative x. And integrating this will give you negative e to the power of negative x. And integrating that will give you positive e to the power of negative x. So how beautifully it rolls over. And finally, integral e to the power of negative x is negative e to the power of negative x. We have now done the integration and the differentiation. We can start picking our terms after assigning the signs. So assign alternating signs: positive x to the power of 4, negative 4x cubed, positive 12x squared, negative 24x, positive 24, and so on. And what is our first term of this integration? You pick our result like this: x to the power of 4 times negative e to the power of negative x. So multiply values below u with values below dv like this: x to the power of 4 times negative e to the power of negative x. That gives you negative x to the power of 4 e to the power of negative x. That's our first term. What's the next term? It'll be negative 4x cubed times positive e to the power of negative x. That would be minus 4x cubed e to the power of negative x. What's the third term? Will be 12x squared times negative e to the power of negative x. So that will make the expression negative. That will be minus 12x squared e to the power of negative x. Minus 12x squared e to the power of negative x. Our next one, 24 is negative and this is positive. So it will be minus 24x times e to the power of negative x. And finally, plus 24 times negative e to the power of negative x will be negative 24 e to the power of negative x. All right. What can you pull out from these terms? A negative e to the, you can see all these terms are negative. So a negative e to the power of negative x can be taken out, leaving x to the power of 4 plus 4x cubed plus 12x squared plus 24x plus 24 plus c as our result. Isn't this a beautiful way to integrate quantities like this? Yes. Okay, let's move on. Well, you can see only certain forms can be integrated like this, so you cannot depend on it for all integration by parts methods. Alright, now I want you to try this on your own using the table method. Integral x over e to the power of x dx. Use the table method to do this on your own and let me know if you have any problem. The answer should be this: negative x plus 1 over e to the power of x plus c. Okay? Alright, let's look at more of integration by parts. Find the integral, integrate x cubed ln x dx. Now, your tendency immediately will be to go and look and say x cubed, yes, I can integrate it continuously to get 0. Well, you'll be in trouble in this particular case and in many other cases. Why? Because if you take x cubed as your u, then you will take ln x dx as the dv. But a quantity that you choose as dv must be a form that you can integrate. Now, do you know how to integrate ln x dx? What is integral of ln x dx? I don't know, and I'm sure you don't know. So obviously, you cannot leave ln x dx as dv simply because you cannot integrate it. And so, in this case, we need to change. How do we identify our u and v? Because ln x cannot be easily integrated, it cannot be your dv. And therefore, you need to choose ln x as your u. If it cannot be your dv, then it has to be your u, is that right? So we choose u equal to ln x. If u equal to ln x, what is du? What is the derivative of ln x? The derivative of ln x with respect to x is 1 over x. And therefore, what is the differential of ln x? It is 1 over x dx. So, u equal to ln x, du is 1 over x dx. Well, if ln x is u, then your dv will be x cubed dx. Is that right? So your dv is x cubed dx. Alright, in that case, what is your v? V is obtained by integrating this. What do you get if you integrate x cubed dx? What is integral x cubed dx? Power rule will be x to the power of 4 over 4. So v will be x to the power of 4 over 4. So we have u, we have du, we have dv, we have v. What is the form of the integral? Integral u dv is u times v minus integral v du. So u times v, u is ln x, v is x to the power of 4 over 4. So u times v will be ln x times x to the power over 4. Is that right? That's your ln x is your u, x cubed dx is your dv. So u times v, u is ln x, v is x to the power of 4 over 4. uv minus integral v du. v is x to the power of 4 over 4 and du is 1 over x dx. Well, now simplify this. X cubed, x to the power of 4 over x will be x cubed, and this 1/4 can be taken out. Is that right? So identify them one more time. That's your u, that's your v, that's your du, and of course that's your v. So this will be, I'm going to write it as x to the power of 4 ln x, is it alright? X to the power of 4 ln x divided by 4, that is this term, minus this 1/4 comes out, 1/4 times integral x cubed dx, and this can be now done very easily. So that will be x to the power of 4 ln x over 4 minus 1/4 times integral x cubed dx is x to the power of 4 over 4 plus c. And now can we simplify this? Yes, x to the power of 4 over 4 can be factored out, or x to the power of 4 over 16. This term has 16 on the denominator, so we will factor out x to the power of 4 over 16. Remember, then the denominator and numerator of this will get multiplied by 4. So when x to the power of 4 over 16 is factored out from here, what is left here will be 4 ln x. So x to the power of 4 over 16 factored out, leaving a 4 ln x minus 1 plus c. And that's the result of our integration. Can you write 4 ln x in a different form? What is 4 ln x? 4 ln x is the same as ln x to the power of 4. If you want, you can also write it like that. Alright, another one. Evaluate the integral. Integral x cubed e to the power of x squared over x squared plus 1 all squared dx. That's a little tough one, is that right? X cubed e to the power of x squared over x squared plus 1 whole squared dx. Now the clue here, if at all there is a clue, you need to pick a dv that can be integrated. Now, you see the denominator x squared plus 1 all squared. Now, when you have a denominator with x squared, in order to integrate it, there must be an x on the top. Why? Because if you want to make x squared plus 1 equal to u, then 2x dx will be your du. That means you need to replace an x dx. You need an x on the top to integrate it. And therefore, look at this and say, we can choose x over x squared plus 1 to the power of 2 as our dv. Why? Because that can be integrated. You see, let me write down that for you. You see, the quantity x over x squared plus 1 to the power of 2 can be integrated. Now, why do I say it can be integrated? Because of the denominator x squared plus u, we can do it by a simple substitution. Now, let me show that quickly for you. We make a substitution, x squared plus 1 equal to u, which gives me 2x dx equal to du or x dx equal to du over 2. Now that will make this expression as x dx. This is of course that x dx will be du over 2, and x squared plus 1 is u. That will be 1 over u squared du over 2. That means you can integrate it like this. Alright, let's move on and pick our u and v. Now I was explaining why you got to look at the dv form, a form that can be integrated. What is the form I said that can be integrated? X divided by x squared plus 1 all squared. That must be the form that you take as dv. So your dv will be x over x squared plus 1 all squared dx. That means your u will be then x squared e to the power of x squared. Is that right? So we decided on our u is x squared e to the power of x squared. I hope you understand why this became u, because this x cube we wrote as x times x squared, and the first x we took along with the dv, x over x squared plus 1 to the power of 2. Alright, if you have your u, then you got to find your du. Let's find the du. Du will be, remember, it will be x squared times the derivative of e to the power of x squared. What's the derivative of e to the power of x squared? So that will be x squared times the derivative of e to the power of x squared. Remember, the derivative of e to the power of anything will be e to the power of whatever that is times the derivative of that quantity. So derivative of e to the power of x squared is e to the power of x squared times the derivative of x squared is 2x. So we are using the product rule there. To find the derivative of x squared times e to the power of x squared is x squared times the derivative of e to the power of x squared plus e to the power of x squared times the derivative of x squared is 2x. I hope you understood this. If u equal to x squared e to the power of x squared, du is, find the derivative of this. X squared times the derivative of e to the power of x squared is e to the power of x squared times the derivative of x squared plus e to the power of x squared times the derivative of x squared is 2x. Whole thing multiplied by dx, because we find the differential. So we have our du. Now this can be written as 2x e to the power of x squared is common, so we factor that out. That will be 2x e to the power of x squared times x squared plus 1 dx is our du. So we got our u and we have our du. What's our dv? Our dv is x over x squared plus 1 to the power of 2 dx. Well, to find v, we need to integrate it. So v equal to integral x over x squared plus 1 all to the power of 2 dx. And how do you integrate it? I just showed it to you. Use a substitution, x squared plus 1 equal to u. So substitute x squared plus 1 equal to u. That gives me 2x dx equal to du. The differential of x squared is 2x dx. Differential of 1 is 0. Differential of u is du. And therefore, what is your x dx? You can see I've used the colors there. When x squared plus 1 becomes u, what is x dx? X dx will be du divided by 2. So this will be replaced by u, and x dx will be replaced by du over 2. We have now integral 1 over u squared du over 2, and that 1/2 comes out It'll be 1/2 integral 1 over u squared du. Alright, I've been asking you this many times. What is integral 1 over u squared du? You can actually use the power rule there, but that is a standard integral that you can remember. Integral 1 over u squared du is negative 1 over u. There you go. So that will be 1/2 times negative 1 over u. And we replace our u now. U is x squared plus 1. So our v, we have been looking for v, and that's our v. V is negative 1 over 2 times x squared plus 1. Alright, I filled this page with our u, du, dv, and v. We have now all those 4 things. Alright, let's carry those 4 things to the next page. We are integrating this, and we have identified our u. We have now our du. We have our dv, and now we have our v. So we go and use the formula. What's the formula for integral u dv? It'll be u times v, uv, minus integral v du. That's what we are going for. Alright, so we have our u, we have our du, we have our dv, we have our v. Keep a watch on this. And integral u dv equal to uv minus integral v du. Let's put all those things in there. So integral x cubed e to the power of x squared over x squared plus 1 all squared dx. That's our original expression. And we picked u and v like this. So that will be u times v. That's our u, this our v. And v is negative, so the negative sign will be x squared e to the power of x squared divided by 2 times x squared plus 1. I hope you understand that. U multiplied by v. Multiply these two quantities. That will be the numerator, and that will be the denominator with this negative sign. So this is our uv minus integral v du. Look at that. This is v, that is our du. Since v is negative, that quantity is negative. And it will be, v will be negative 1 over 2 times x squared plus 1. That's our v. And this is our du. Alright. And if you notice here, x squared plus 1, x squared plus 1 will cancel. 2 and 2 will cancel. Let's cancel those. There you go. And therefore in the next step it will be x squared e to the power of x squared over 2 times x squared plus 1 plus integral, what is left here is x e to the power of x squared dx. That's the only thing left over there. And this can be integrated. How? Tell me. I say emphatically that can be integrated. How? Tell me how you can integrate this. Well, look at the power x squared and look at x dx. Does a light go on in your brain? It should, because you can now substitute u equal to x squared, and then du will be 2x dx. You can replace x dx by du. So immediately you must see that this can be integrated by a simple substitution. So we substitute what? Substitute x squared equal to u and find the differential of both sides. It will give you 2x dx equal to du. Now when x squared becomes u, then what is x dx, the remaining term? X dx will be du over 2. So this integral now becomes this term is going to remain the same. So that will be whatever we have here plus integral e to the power of x squared becomes e to the power of u, and x dx becomes du over 2. Now look how simple it became. And that 1/2 will come out. That will be 1/2 integral e to the power of u du. What's integral e to the power of u du? It will be e to the power of u. So that will be e to the power of u times that 1/2. And we put back that u. What is our u? U is x squared. So that will be x squared e to the power of x squared divided by 2 times x squared plus 1 plus 1/2 e to the power of x squared plus c. And we can factor out something, can't we? Yes, let's factor out e to the power of x squared. You can see e to the power of x squared in both cases. And I'm factoring out 2 times x squared plus 1 on the denominator. Now, how can I do that? When I take out on the denominator 2 times x squared plus 1, that is in here, but x squared plus 1 is not here. That means the numerator will get multiplied by x squared plus 1. Is that right? So, watch again. We take out e to the power of x squared divided by 2 times x squared plus 1. Let me see if I can show that to you on the board. Well, we're going to take out this, and in the next one we don't have an x squared plus 1. So what I'm going to do is multiply x squared plus 1 on the numerator and also on the denominator. Now, you can see this is going to come out. Alright? Now, what I've done is in the second term, I multiplied the numerator by x squared plus 1, the denominator by x squared plus 1, and what have you taken out? E to the power of x squared over 2 times x squared plus 1 here, e to the power of x squared divided by 2 times x squared plus 1. That's going to come out, leaving in the first term an x squared. Is that right? And in the next one, an x squared plus 1. But we have a negative sign there. So, when you take out this, okay, what is left there is a negative x squared in the first term, and what is left in the second term will be x squared plus 1. So, I have written x squared plus 1, that is this x squared plus 1, minus x squared are the remaining terms. I hope that is clear. Alright, you look at this again and practice these kind of skills. Alright, there we go. And so the final result is, you can see that x squared minus x squared will cancel. What is inside this parenthesis is just 1. So the answer is e to the power of x squared divided by 2 times x squared plus 1 plus c. And that is the result. Now, this has been a pretty involved problem, so you need to practice that. Now, I know when you do this on your own, you feel, when you do it on your own, you know that the thrill you get. You must get that thrill. That's when I know, or when you know, that you really understand this. Alright, let's do another one. Evaluate the integral. Integral x over square root 2 plus 3x dx. Now, how about this? What's the method of doing that? Decide on your u and dv. Well, your u equal to x. Why? Because 1 over square root 2 plus 3x dx can be integrated. That's right. So your u equal to x, du therefore equal to dx. What is your dv then? If u is x, your dv will be 1 over square root 2 plus 3x dx. That's right. How do we integrate this? By now, you must be able to integrate these kind of quantities very easily. Well, we substitute 2 plus 3x equal to u. And then replace your dx in terms of that. Alright, so we have v equal to integral 1 over square root 2 plus 3x dx. And I have colored 2 plus 3x, which means substitute 2 plus 3x equal to u. And that will give you the differential 3 dx equal to du, or dx equal to du over 3, and bring it over there. That will be integral 1 over square root u, 2 plus 3x is our u, and dx is du over 3. And of course, 1/3 comes out, and 1 over square root u is u to the power of -1/2. We have done a number of these in previous occasions. What is integral u to the power of -1/2 du? It will be u to the power of -1/2 plus 1 over -1/2 plus 1, which is u to the power of 1/2 divided by 1/2. That's right. So that will be 1/3, u to the power of 1/2 divided by 1/2. And what will be divided by 1/2? That 2 will go up. So that will be 2/3 u to the power of 1/2. And u to the power of 1/2 is square root of u. And square root of u is square root of 2 plus 3x. So our v is 2/3 square root 2 plus 3x. Once again, our u is x, our du is dx, our dv is this quantity, and our v is this. And now we can take these and use our integration by parts formula. You got u, du, dv, and v available there. Therefore, integral u dv is uv minus v du, and this is our original form of integration. And our x is our u, 1 over square root 2 plus 3x dx is our dv. And so, what's the uv? U times v will be x times 2/3 square root 2 plus 3x, that's our uv, minus integral v du. Integral v du will be 2/3 square root 2 plus 3x dx. Okay, now that's equal to, this will be 2/3 x square root 2 plus 3x minus 2/3 of integral square root 2 plus 3x dx. That can be integrated easily by using a substitution. What is a substitution? I have given it away by coloring it. So substitute 2 plus 3x equal to u. That gives you 3 dx equal to du, or dx is du over 3. Bring it over there. That will be the same thing, u times v minus 2/3 integral square root u, dx is du over 3. And now this 3 comes out to make that 2 over 9 square root u du. So that will be 2/3 x square root 2 plus 3x minus 2 over 9 integral u to the power of 1/2 du. And you know how to integrate this. Integral u to the power of 1/2 is u to the power of 3 over 2 over 3 over 2. There you go. So that term does not change. Minus 2 over 9 u to the power of 3 over 2 over 3 over 2. And combine this. This 2 will go up, will make it 4, and this 3 will multiply with 9. So the number here will be 4 over 27, and replacing your u with 2 plus 3x, you have 2/3 x square root 2 plus 3x minus 4 over 27 u to the power of 3 over 2, 2 plus 3x to the power of 3 over 2 plus c. Okay, how do you simplify this? Now remember, square root 2 plus 3x is the same as 2 plus 3x to the power of 1/2. So this is actually square root 2 plus 3x multiplied by 2 plus 3x. That's what you see. 3 over 2 is 1/2 plus 1. So I can actually factor out a square root 2 plus 3x, can't I? I hope you understood this. Let me write down that for you. You see, this quantity 2 plus 3x to the power of 3 over 2 is actually square root 2 plus 3x times 2 plus 3x. Because square root 2 plus 3x is to the power of 1/2. 1/2 plus 1 is 3/2. So I can actually factor out a square root 2 plus 3x from there. And is there anything else? Also a 2 over 27. So I'm going to factor out a 2 over 27 square root 2 plus 3x and see what is left after factoring that out. What is left in here? Now, in the first term, you only have 2 over 3, but I'm factoring out a 2 over 27. That means this will get multiplied by 9. So this has come out. You have multiplied the numerator by 9, and 2 over 27 has come out. So what is left there is a 9x. So after factoring out 2 over 27 square root 2 plus 3x, what is left in here is a 9x. I want you to understand that. What I did is multiply numerator by 9, denominator by 9 to produce a 27. And 2 over 27 came out, leaving a 9x. But this also came out. Minus, what is left here? 2 over 27 came out, leaving a 2 there. And square root 2 plus 3x came out, leaving a 2 plus 3x there. There you are. So that's minus 2 times 2 plus 3x. And now simplify that. You get 2 over 27 square root 2 plus 3x times 3x minus 4 plus c is that result. Again, a very good one. Try and practice this one more time. All right, another one. Evaluate the integral. Integral arc cos x dx. Arc cos x dx. Can you decide on a u and a v? Well, you cannot integrate arc cos x. You have not learned how to do it. So obviously that cannot be dv. So can that be u? Do you know how to differentiate arc cos x? Yes, we have done that. So arc cos x can be differentiated. So that can be your u and dx can be your dv. That's the way to go. So we have u equal to arc cos x. What is the derivative of arc cos x? The derivative of arc cos x is negative 1 over square root 1 minus x squared. If you've forgotten it, you've got to go back and refer to it. The derivative of arc cos x is negative square root 1 minus x squared. Therefore, du is negative 1 over square root 1 minus x squared dx. So you got u and your du. Our dx will be our dv. If dv equal to dx, what's our v? V will be equal to x. You see, it became actually very simple. All right, let's go here. Integral v du is uv minus integral v du. Therefore, integral arc cos x dx is uv, u times v is arc cos x times x, which is x arc cos x, minus integral v du, v du, v is x, du is negative 1 over square root 1 minus x squared. That's how the negative came. So the product of v and du is this. Now these two negatives become positive, is that right? And in order to do this integration, we make a substitution. Because there is an x dx there, we can make a substitution. 1 minus x squared equal to u, and that will give me negative 2x dx equal to u, or negative x dx as du over 2. So when you replace 1 minus x squared as u, negative x dx will become du over 2. So that becomes x arc cos x minus integral 1 over square root u, negative x dx becomes du over 2. That will be x arc cos x minus this 1/2 comes out, 1/2 times integral u to the power of negative 1/2 du. And of course, integral u to the power of negative 1/2 is u to the power of 1/2 divided by 1/2. That will be x arc cos x minus 1/2 u to the power of 1/2 divided by 1/2. And you can see this divided by 1/2, the 2 goes up and cancels. That means this whole thing will disappear, leaving a 1. This is simply u to the power of 1/2 plus c. And u to the power of 1/2 is square root of u, where our u is 1 minus x squared. So our answer therefore is x arc cos x minus square root of 1 minus x squared plus c. And that is a typical type of integration. And I want you to go back and pick some of these problems from the homework and practice this on your own. A very good method of integration by parts.